Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at another example of solving an equation using Newton's method. In the last video, I introduced Newton's method as a method of solving equations numerically when you couldn't solve them algebraically or by other means. So you start off by making sure your equation is equal to 0, and then you make that your function. Now if you were to draw that function, where it crossed the x-axis is where it equals 0. So you're solving that equation by finding that root. And the idea was you would have to start with an approximation close enough to that root that this method works, and then you would use the formula x2 will equal x1 minus the value of the function at x1 divided by the value of the derivative at x1. That would give you a value of x that's closer to your root than what you started with. And then you would repeat the process again and again. In this video, I want to talk about what happens if you don't know what x1 should be. If you're given a question and you don't know where to start. So let's take a look. So if we had this question asked us to find the positive root of the equation x cubed minus 2x squared plus 4x equals 5, and we want it accurate to 4 decimal places, you could be asked any number. I just randomly chose 4. What you're going to do is find x2, then x3, then x4, and so on. And once you get a value of x that's same as the previous value of x to that many decimal places, then you're done and you know that your answer is accurate to that many decimal places. So what we're going to do first here is we're going to set this equation equal to 0. So it'll be x cubed minus 2x squared plus 4x minus 5 equals 0. That's very, very important. If you don't do that, this is not going to work. Then we make that our function. Once it's equal to 0, that's what our function is equal to. So f of x will equal this. We want our positive root of this equation. We have no idea where to start. When you're working with a polynomial function, we've discussed continuity in a previous video, but this function is continuous for all values of x. So that means if our y value changes from positive to negative, or negative to positive over an interval, then it must have crossed the x-axis in that interval. So the root must be between the values that where it changed. So what we want to do is find out where y changes from a positive value to a negative value, and then we'll get an idea of where our root is. The best way to do that is set up a table of values. And I'm going to start at 0. So when x is 0, we put a 0 in, y will equal negative 5. Then we put in a 1. So 1 cubed, so we just find f of 1. So it would be 1 minus 2 plus 4 minus 5, which is negative 2. Then we put the x value of 2 in. So we get 2 cubed, which is 8, minus 4 times 2 is 8, plus 8 minus 5, that's positive 3. Notice that the function went from a negative value to a positive value. So that means that it crossed the x-axis, so that means there's a root between x equals 1 and x equals 2. So now we have an idea of where to start with our approximation. I would probably pick 1. I often like to start with a whole number as my first guess, because that's a little closer to 0 than this. But you could, take 1.5, for example, go in between, halfway in between, and use that as your first guess. As long as you've picked either 1, 1.5, or 2, or something in that range, you're going to converge to the correct answer regardless. So let's let x1 equal 1. In order to find x2, which is this formula, this is Newton's formula for solving an equation, we need the derivative. So let's find the derivative of this function. It'll be 3x squared minus 4x plus 4. Now I can find x2. So x2 will equal 1 minus the value of the function when x is equal to 1. So that would be 1 cubed minus 2 plus 4 minus 5 divided by the value of the derivative when x is 1. So that would be 3 minus 4 plus 4. So that's going to be 1 minus a negative 2 over 3. So x will equal 1 plus 2/3, which is 1.666. Repeating, I'm going to show my answer rounded off to 4 decimal places, but when I use this to do further calculations, I'm going to use the actual value, 1.666, that I obtained on my calculator. So don't use this to find x3, use the value that's on your calculator. So again, you need to know how to store it on your calculator and recall it from your calculator. Now to find x3, I don't want to write this number down because I'm not actually using the rounded off number. So I'll just put x2, but we just plug into our formula again. So we're going to store that number in our calculator and we're going to recall it minus, we're going to use brackets here, and then recall the number, cube it, minus 2 times the number squared, we have to recall it again, plus 4 times the number, recall it again, minus 5, end of bracket. Then you're going to divide by bracket 3 times, recall the number, square it, minus 4 times, recall the number, plus 4, end of bracket. And if you've put enough brackets in there, you should get the correct answer. Of 1.5359. So you can see that we're getting closer. We went from 1 to 1.6667, now 1.5359. So the difference between these two answers is smaller than the difference between these two answers. So I know that I must be converging towards the correct root. Now that we've obtained x3, which is not equal to x2, we have to use the process again. So we're going to find x4 by plugging the value on our calculator, which I've rounded off to this, into our formula. When we calculate it, we should get 1.5260. So you should try that with your calculator and make sure you are able to get the same results that I am. We're getting close, but they're not the same to 4 decimal places. So we're going to do the process again using the new value that we have for x, which is now on your calculator. Plug that into the same formula. And then when you round off to 4 decimal places, x5 should be 1.5260. Because this is the same as this, we know it's accurate to that many decimal places. So the root to this equation is 1.5260. You can always check it, plug it back in. So it might be harder to find, what to use as x1 if your function isn't continuous, because if it's not continuous, you don't know that it necessarily crosses the x-axis when the y value goes from a positive to a negative or a negative to a positive. In those cases, you might need to draw a graph of the function so that you know whether it's continuous over the interval that you're looking at. So practice as much as you can with Newton's method for solving equations. It's a tedious, time-consuming process, but it's pretty amazing that it can solve an equation that we weren't able to solve algebraically. Practice, and we'll see you on the next video.